Alright, today we're going to be talking about curves and polygons and circles, and we're going to be looking at some definitions of those, and we're going to be looking at some properties of triangles. So we're going to be looking at triangles and quadrilaterals also, and curves and circles. So a basic undefined term, curve, and again this is talking about Euclidean geometry, is used for describing figures in a plane. So again, basically what we're saying here is there's a simple curve, and a simple curve can be drawn without lifting your pencil from the paper, and this is the important part, without passing through any point twice. So if I draw this, which means I haven't picked up my pencil, that's not simple because right here I touched a point twice. So that's not a simple curve. A simple curve could be a circle or some other shape like that. A closed curve has its starting and ending point at the same point, and it's also drawn without lifting the pencil from the paper. So that example that I drew there that looks sort of like a circle would be a closed curve because I picked up my pencil, I drew the complete circle, and the starting point and the ending point are the same points. So here we have a simple curve, the first one, because I drew this. I can trace this shape with my pencil, and hopefully I do a better job than I'm doing, and then I don't pick up my pencil and I'm not overlapping any of my lines. It is closed because I started and stopped right here at the same point. This is a simple curve. None of the lines overlap each other, but it is not closed because the starting point's here and the ending point's here. They're not the same point. This one is not simple. I started right here, I come down here, and I go around, and it's not simple because they overlap right here, but it is closed because the starting and ending points are the same points. This one is not simple, and it is not closed because I overlapped right here, so that's not simple, and the starting and ending points are different. So we talk about two different names for polygons. We talk about a convex polygon, and the opposite of convex, a term that I'm familiar with, is concave. We're not going to talk about that in this section. So a figure is said to be convex if given any 2 points inside the figure, the line segment AB is completely inside the figure. So AB, I drew it right here, and I connected A and B together, and it's completely inside the picture. If I pick an A here and a B here and I connect them, it's inside the picture. If I pick an A right here and a B right here and draw a segment between them, it's inside the picture. So no matter where I pick A and B in the picture, as long as when I connect them together, the entire segment AB is in the picture. On this one, I can pick an A and a B value right here, and I can connect them together, and I can say A and B, the segment, is inside the picture. But I can also pick an A and a B up here, like they've shown you, and this part of the segment right here is not inside the figure. So this is what we refer to as a concave shape, and the first one that you see here is convex. Another way of thinking about concave is one of the sides is caving in. So that's another way I look at it. So a polygon is a simple, so remember simple means that there are no overlapping lines, closed curve, which means all the beginning and ending point are the same, made up of only straight lines, so there are no curved segments, and the line segments are called the sides, and where they meet are called the vertices. So polygons could be like a rectangle or a square or a triangle or a trapezoid. These are the different things we're going to talk about today. A regular polygon is a polygon where all of the sides are equal and all of the angles are equal. And a very good example that most people are familiar with is just a square. And with a square, all the sides are the same, and all of these angles are 90 degrees. They're perpendicular. Remember the word we learned last section. So the first two examples here are convex. Again, if you notice that if I pick any 2 points inside and connect them together, that they would stay inside. If I picked any 2 points like right here and right here, if I connect that segment together, the segment's inside. This one is concave or not convex. If I pick 2 points right here and connect them together, I end up with this part over here outside. So convex polygon, not convex or concave. And then these polygons are all regular. This is a triangle, all the sides are the same. A square, a pentagon, hexagon, and octagon. And we're going to talk about that now. So these are some of the names of shapes that you need to be familiar with. A three-sided shape is called a triangle, which you should be familiar with. A four-sided shape is a quadrilateral. Q-U-A-D means four, quadrilateral. Five-sided shape is pentagon. Six-sided shape is hexagon. Seven-sided is heptagon. 8 is octagon. Think about an octopus. 9 is nonagon, and 10 is decagon. And you need to be familiar with those shapes because they will usually say something to the effect that there is a regular nonagon, find the value of the sides or something like that. So then we have some angles, some triangle information. If I have a triangle where all of the angles are acute, remember acute we talked about is an angle that's between 0 and 90 degrees. So all of these angles inside this triangle are less than 90 degrees. So this is called an acute triangle. If one of the angles is right, like this angle, see the 90 degree mark there, if one of the angles is right, then it's called a right triangle. If one of the angles is obtuse, that means between 90 and 180. If one of the angles is obtuse, this one's obtuse, then it's called an obtuse triangle. Okay, now this is classifying the triangles by their sides, classifying them by the sides. So equilateral. Equa means equal. Lateral means sides. So equal sides mean all of the sides are equal. Now what I'm going to do is I'm going to put a little hash mark on each of the sides to show that they're all equal. If two sides are equal, then it's what we call an isosceles triangle. These two sides are equal. If none of the sides are equal, none of these sides are the same, then it's called a scaling triangle. So again, you're going to get problems as we go through the section that talk about, that you have a scaling, right triangle, and they're going to ask you information about that triangle. So just keep that in mind. Scaling just means none of the sides are the same. Right means one of the angles is 90 degrees. So here are just some basic quadrilaterals that you need to be familiar with. A quadrilateral. One quadrilateral, remember quadrilaterals are four-sided figures. Sorry, let's go back. Okay. Quadrilaterals are four-sided figures. If we have something called a trapezoid, it's a quadrilateral with one pair of parallel sides. So parallel means that they do not touch each other. So this side is parallel to this side. And these two sides are not parallel. These are called the legs. And these are called the bases. So we have base 1 and base 2, and it doesn't matter which one's the first one, which one's the second one. And then these are called the legs of the trapezoid. A parallelogram is a quadrilateral or four-sided figure with two pairs of parallel sides. So the opposite sides are parallel, and then these sides are parallel. And I'm just using the arrows to mark to show that sides are parallel. We also know that the top and the bottom of this are congruent or equal. So the opposite sides, it has two pair of parallel sides, and also opposite sides are congruent, are equal. Okay, so if you use some of your properties of parallel lines, if this side is parallel to this side, cut by a transversal, then what do we know about these two angles? Are those two angles the same, or are they different? And since they're different, they're going to be supplementary. And remember, supplementary means they equal 180. So keep some of those things in mind as you're going through these. A rectangle is a parallelogram with right angles. So all of these angles in the corner are right. Now, watch out for your wording here. It's saying it's a parallelogram. So that means that the opposite sides are also parallel, and the opposite sides are also equal to each other. We also know in a rectangle, the line that goes from one corner to the other is called a diagonal. The diagonals on a rectangle are the same value. So the diagonals are equal. And then our last two shapes are squares and rhombuses. A square is a rectangle where all of the sides are equal. So if it's a rectangle, that means it has all the properties of a rectangle. So that means we've got 90-degree angles in the corner. Opposite sides are parallel, opposite sides are equal, but all of the sides in a square are equal to each other. Okay, a rhombus is our last one. A rhombus is a parallelogram that has equal sides. So all of the sides of the rhombus are equal to each other. The opposite sides are parallel. And we also have those same properties that we had before. These two angles that are in red are supplementary, which means they add up to be 180 degrees. If I look at the two angles that I'm going to call X, if I look at this angle and this angle, notice that both of those angles are obtuse, and those two angles are equal to each other. So the red ones that I had up there a second ago are supplementary, and they equal 180. And the green ones that I have in X's are congruent or equal to each other. So we're going to talk a little bit about triangles now. There's this angle sum theorem of a triangle, and that is that the sum of all of the measures of any triangle is always 180 degrees. And what you can do, a pretty popular activity, is to take any triangle and cut off the end pieces of the triangle. So you want to cut this piece off right here, and then you're going to cut off this piece right here, and you're going to cut off this piece right here. And if you take those three pieces and form them together and put them on a piece of paper, you will end up with those three pieces ending up to form a straight line. So that's how you can primitively prove that the sum of the measures of any triangle is 180 degrees. So if we have this example here, I know I want to find the measure of each of the angles. So if it's a triangle, I know that the three angles of a triangle have to equal 180 degrees. So that's what I'm going to do. I'm going to set up an equation, x plus 20 plus 220 minus 3x. The three angles of the triangle have to equal 180 degrees. So I took the first angle plus the x plus 20, the second angle, plus the 220 minus 3x, and I add them together to get 180. I'm going to combine like terms now, so I'm going to combine x plus x minus 3x, and I'm going to get negative 1x. I'm going to combine 20 and 220 together and get 240. And all of that is equal to 180. I'm going to keep solving. I'm going to subtract the 240 from both sides. And I get negative 1x equals negative 60. So getting rid of the negative sign, x has to equal 60. So then again, substitute that back in to the missing angles, and I would have 60 for this angle, I would have 80 for this angle, and that means that this angle has to be 40. Alright, so when we look at this picture, we'll notice that we have our typical triangle. So angle 1 and angle 2 and angle 3 equal 180 degrees. But then we see this angle 4 out here. And angle 4 is what we call an exterior angle because it's outside the triangle. And angle 2 and angle 3 are what we call remote interior. So angle 2 and angle 3 are not adjacent to or next to angle 4. And so what the exterior angle theorem says is that if I add these two angle measures together, they will equal that exterior angle. So the measure of angle 2 plus the measure of angle 3 is going to equal the measure of angle 4. So let's apply that to this problem. I know that these two angles added together, since they're on the inside, have to equal that exterior angle. So 3x minus 40 equals x plus 20 plus x. I'm going to continue to solve that. So 3x minus 40 equals 2x plus 20. I'm going to subtract the 2x from both sides. Scoot over here a little bit. So I get x, or 1x, minus 40 equals 20. I'm going to add 40 to both sides. So I get 1x equals 60. And technically I'm going to divide by 1, so x equals 60. So again, take that information and substitute it into the problem, and you can find the measure of the exterior angle is going to be 140 degrees. Alright, so our next shape that we're going to talk about are circles. So a circle is actually not a polygon because circles do not have sides. They do not have vertices and they do not sides. So a circle is a set of points in a plane, and each point is the same distance from a fixed point, and that fixed point is called the center of the circle. So in a circle, we have some different pieces that we have here. Our first piece is called a radius or radii, and the radii is a segment that connects the center of the circle to any point on the circle. That's the radii. A chord is a segment that connects the endpoints of the circle. So if you have any 2 points on the circle, a chord connects those 2 points together. Now, if you were to connect through the center of the circle, you would have a chord that is called a diameter. The diameter cuts the circle into semicircles. So let me give you a couple pictures here. So if we have a circle, look here, my best attempt at a circle. Here's the center of the circle. Please pretend that these are all the same. The segment that I've drawn here is called a radii, so I'll call that R. A chord is any segment that goes from one side of the circle to another side of the circle. So this is a chord. The diameter is the chord that goes through the center of the circle. So this is our diameter. So now the diameter cuts the circle into two semicircles, or two half circles. A tangent is a line that is outside the circle that touches the circle at one point. It's a little bit harder to draw a tangent. So a tangent touches, that's not a very good line. Okay, so let's try again. A tangent is a line that touches the circle in one point. I've got a better slide on the next slide. And a secant is a line that goes through the circle and touches the circle at 2 points. So these two definitions at the bottom are lines that involve the circle. So they're lines that touch the circle in 1 point, or a line that touches the circle in 2 points. The two definitions that you see here are segments. So they have a start and a stop point. They do not go all the way through the circle completely and come out the other side. All right, so here's a picture with some good examples. So I gave you that PR is the diameter. OQ is a radius. So if we go back over here and look again, OP is also a radius. And OR is also a radius. PQ, if I notice the notation over here, PQ with the bar on top, not the line segment, is a chord. PQ with the arrow symbol on top is a secant. RT, the line segment RT, is a tangent. Notice it's all outside the circle. T is outside the circle, and R is on the circle. So it's a line that touches the circle in one spot. Now PQ is what we call an arc. An arc is a piece of the circle. So PQ is an arc. Another arc in the picture is QR. And notice the arc symbol is an arc above the letters, is an arc. Now what we have here is what we call an inscribed angle. So when you think of inscribed, you think of something inside. So inscribed means an angle that is inside the circle. And when it is inscribed, it's going to touch the circle at one point. So here's my angle right here. And you'll notice that it is inscribed. It is inside the circle, in this case half of a circle. And it touches the circle 2 times. The sides of the angle touch the circle twice. And the vertex of the angle is on the circle. So here's another example of an inscribed angle. And so you'll notice here that the vertex of the the vertex of the angle is down here at the bottom. Okay, it's not going to let me draw. And the angle measure is half of the intercepted arc. So here's what that means. If this arc is 100 degrees, then the measure of this angle is going to be 50 degrees. So let's look at another one. if the measure of this arc is 110 degrees, then the measure of this angle is 55 degrees. Look at another one. If the measure of this angle is 70 degrees, then the measure of the intercepted arc is 140 degrees. So I hope this information helps. Again, keep up with your homework. Let me know if you're having any problems, and keep in touch with me if you are having problems. Have a good day.